This is the time. Welcome to the afternoon season. The first speaker is Tamer Libal. He's an assistant professor in the American University of Paris, but currently he is a visitor in our group, ICR group, and we are very happy that we have Tamer here. So Tamer, please start your talk.
Thanks, Ali. Do you hear me?
Yes, sure. Thank you.
Perfect. So first of all, thank you for inviting me to talk in this seminar, and also congratulations again for your defense yesterday. In my talk entitled From the Deontic Logic to the Lawyer's Practice, in fact, it's the other way around. It's from the lawyer practice to the Deontic Logic. I think is a bit different than other talks today, because it's more of a personal, ongoing account of an ongoing effort to create the Deontic logic-based application for the legal domain. So I will talk about the requirements that I found on the way and the status. So first of all, why applications? And why applications during this seminar on Deontic logic? So first of all, the workshop is entitled Deontic logic in the next 10 years. And when I look for the future, I see robots replacing also lawyers and jurists and judges. This is the far future, of course. But if we try to restrict ourselves only for the next 10 years, I can also see some kind of automated reasoning and applications already applied to the legal domain. And you all know that in the last 20 years, there were already quite a lot of artificial intelligence applications in the legal domain, but they were mainly machine learning-based tools. And these tools suffer from various problems in the legal domain, not only in the legal domain, but which are especially important in the legal domain, such as they are biased, because they're based on data, and the data doesn't cover rare cases. There are black boxes, so it's many times not possible to understand. Of course, people are working on making it better, but I didn't see it sufficient solutions, and certainly not the level of solutions that you have in automated reasoning of explainability. And they also always have some kind of margin of error. And in the legal domain, these problems are especially important because, of course, you don't want a tool that is biased to a certain population or certain cases, etc. You need to be able to explain the reasoning because you might need to defend it. And you also want it to be certified because if you're using this tool in order to help yourself in your work, you don't want to harm your reputation by making bad decisions. So in my opinion, when we look into the next 10 years, we should see, and it's not only my opinion, of course, it's the European Commission opinion, and many other bodies think that machine learning alone cannot guarantee different things like ethics, etc. In the future. So it seems to me that the next 10 years we should see more automated reasoning applications in law. And this talk is more or less the first step towards that I made. What's the relationship to this workshop? So not only but it might be interesting to hear my personal account and the problems I found, but it also can shed light, so the practical applications can shed light over the properties of the Deontic logic that you need. So we heard before that standard Deontic logic is clearly too naive for many applications, but and this is of course an extreme example. But if an application requires only standard Deontic logic and it has the best computational properties, then why not? It might be the right logic for some applications. So applications can drive the requirements for the Deontic logic in some cases. Okay, so when I say applications and Deontic logic, what do I mean? So first of all, we need an expressive logic which can capture both the problem and the domain. We need to automate reasoning over that. So we need some tools over this logic, reasoning over this logic. But these are the standard things that we think about, but we also need other things. We need human interfaces because humans still need to interact with these tools, with these applications. not the least because we have lots of legal knowledge that we want to put in, and we need to know that what we do is correct, is right in a certain context. So we need at least some interface for entering correct legal knowledge. We also need a similar interface for entering problems. And third, we need some interface for understanding the results. So in this talk, I try to give a very shallow but wide picture of all the requirements put together using different levels of abstraction. Normally, there will be a very high level of abstraction. So this is another difference from other talks, I believe. And my personal interest here is that it's a part of a proof of concept that I try to run. I want in 2 years to have some kind of an application that can really do very well 1 or 2 tasks done today by human and be based on Deontic logic. Okay, so let's talk about first 2 possible applications. So I can think of at least 2 possible applications. One of them is you use Deontic logic and interactive verification to verify normative or legal arguments. So this approach was tried very successfully in hardware-software verification. And today it's very hard to imagine some domains like car safety and train safety without doing some software and hardware verification using those tools. But if you think about 30 or 40 years ago, nobody thought about this, or people thought about it, but it was very far from practice. So this is a domain that will get more and more interest, and you can do very interesting things. Another type of application is to actually replace some of the legal expert work. So in this case, we don't, so in the previous case, when we try to do a verification, interactive verification, you clearly require logical expertise by the user. In the other one, you don't require any logical expertise. So you just want to give somebody with no logical expertise, but with other expertises, and this person will be able to use and trust the tool without understanding the logic behind it. And I'm going to focus on the second. So this is the high-level view of all the issues and the components that I have identified that needs to be fixed in order to get to meet the challenge, having a prototype which can replace some of the human work. So let me start just explaining quickly one by one, and in my talk I'm going to go a bit deeper into each one of them, and then I'm going to summarize the results or what I discussed. So first of all, let's start with the problem interface. On the right, you can see some user with no knowledge in logic. It might not even have legal knowledge, but this user wants to use the application. So this is the user of the application. And on the left, you see somebody who might have some logical knowledge, and more importantly, legal knowledge. And this person is responsible on creating the knowledge. I'm going to start on the right. So this person with no logical knowledge, maybe some legal knowledge, it's not mandatory, first of all wants to put some problem. So there needs to be some problem interface. Because the person doesn't understand logic, of course, the problem interface should not require a logical language. So here we can imagine just uploading a document. Because there is such an arbitrary input, we need to have a step for problem translation. And the target for the problem translation is some Deontic logic in our case. So we want to translate problems into a Deontic logic, which is point number 3. On top of that, we want to have some kind of a legal engine, a legal reasoning engine, which can tell you answer for arbitrary questions, what is permitted, of course, normative questions, and maybe even higher level questions like if something is compliant, and maybe different legal other questions. So this engine is sit on top of the automated prover, and it also responsible on translating back and forth the questions and the answers to inform the automated prover. So the next point is that we actually need a software which is very efficient, which can actually execute these queries. This is the point 5, the automated prover. And last, we need, not last, but then we need to translate the result. This is point 6, because the result still needs to be understandable by the user. And of course, we need to present it to the user in a way that it will be meaningful and useful. Okay, so now going to the left, to the person who is responsible on putting in the knowledge. Here, I have only 3 points, 8, 9, and 10. And the first 2, 8 and 9, are some interface for inputting the knowledge and a way of saving the knowledge. Again, this is going to be in the ontologic form. And on top of that, we have some kind of quality control, because the aim here is to replace some tasks of the lawyer. So it means that the quality of the work needs to be at least on par with some of the work done by the lawyer. We are not going to replace the lawyer, but let's say that the lawyer has some, or I'm saying lawyer, but of course it can be anybody who is using the tool, has some task that they need to do, and they need to count on the tool to be at least of a quality of a high level, high quality lawyer or high quality legal expert. So we need some quality control. So let me start from the first point. The problem interface and the result interface. So these things I started to think only recently because they really require talking with possible clients, possible users, intended users of the tool. So you need to meet with these stakeholders, you need to sit with them, you need to understand exactly what kind of applications would most benefit them, and then you need to choose the most interesting use case. Most interesting with regard to the fact that it can be most easily be done and also has enough applications. So here I'm just marking two such use cases. Again, I need to, they are not the formal use cases of my proof of concept. They need to be verified, but they are the initial ones. So the first one is an auditor. Let's say my main domain right now is privacy law. So an auditor wants to check, to get feedback about the compliance of a document against the privacy law. And the use case, imagine the auditor uploads the document. So just put it a Word document or PDF document or whatever, and just upload it to some kind of a cloud service. Inside the cloud service, something happens, and the lawyer gets back a version of the document annotated with what is compliant, what is not compliant, what cannot be proved to be compliant, and if something is proven to be compliant, the tool also tells you why it is compliant, and if the tool was not shown to be compliant, counterexample and some reasons for that. So this is the first use case. And the second use case, a bit different. In this case, a lawyer wants to prepare for court proceedings. So the lawyer wants just to upload the case. I don't know, maybe the format will be an Excel sheet or also a document. And the lawyer wants to get back all the possible arguments and counter arguments, print them, and then when they go to court, for example, they can have all the counter arguments readily available, computed by the tool. So these are two possible use cases. Now that I have these two possible use cases, it's easy to see that they are very far from any formal representation. And some of it is even completely unstructured, so some document of text which you don't even know what are the sections, like let's say some contracts, arbitrary contracts. So we have different possible input. We have semi-structured data. Some of we have this unstructured data, like I just mentioned, but you can also have semi-structured data. For example, some of the things we want to check for privacy law compliance might be business processes, which can be captured using diagrams, which are semi-structured data. Some documents might also have some structure, and software code is also, of course, at least semi-structured. And the output that we are interested in is the Deontic logic. So here I'm explaining not really solutions to the problems, but ideas of how to solve them. This part, the 1, 2, and 3 points in the picture I showed you above, I didn't, and also 7 and 6, well, we didn't do much about that. Okay, so these are the things that are, there is very little work done on top of that, but we thought about them. So some solutions, first of all, you need to have good ontologies, and they will serve all kinds of input. For example, you have the Pronto privacy law ontology, and they will serve as some kind of an ontology for the knowledge and for the problem and for the explanation of the result. Then for the, at least for the unstructured, but also probably for the semi-structured, you need some kind of a natural legal language processing engine. Now, there are already not quite a lot, but there are already tools based on natural legal language processing, which process contracts and using machine learning methods and other things. But the difference here is that we don't try to use data in order to give conclusions. So we're not going to say this is compliant or not based on the data. We are going to just use this engine in order to translate it into a more formal representation. Okay, so of course, indeed, there is a chance of a margin of error here. but at least to me it seems that the dangers are much smaller than, and also you can have some kind of explainability because the user can see the translation and might not agree with it. So there is a less danger of the problems of machine learning when we just use this engine in order to translate an unstructured document into a structured form. Of course, we can also use algorithms for translating semi-structured data into a formula. And we can also think of code analysis, especially dynamic. So there are already results trying to use static and dynamic code analysis for security, for example, for finding security weaknesses in code. One can also look for privacy weaknesses in code using both static or dynamic. For example, if you have some kind of an object-oriented language and you have a variable which denotes some sensitive data and this variable is not encapsulated, this can be already recognized using static analysis. But more interesting is using dynamic analysis. And this means that you try to generate logs, for example, of all the actions, and then you translate these logs into formulae, and then you actually try to run compliance checking over these logs. So there are also works done on this approach. Okay, so now I'm moving forward to the legal reasoning, and this might get more interesting. So what are the requirements of the legal reasoning engine? So first of all, it needs to be expressive and needs to deal with different aspects of legal reasoning, like contrary to duty, obligations, exceptions, or non-monotonic reasoning, different contexts, also unknown requirements, which I cannot think right now, but might come in some cases when the tool is actually placed in deployed in production. And also, of course, it needs to be efficient because when we talk about, let's say, just checking for compliance, so we have a document, we want to check for compliance, we don't talk about one query to the top, or we talk about hundreds of queries of different things, what is permitted, what is obliged. We need to run counter models at the same time as we try to find validity in order to answer the problem from different directions, and then we need to compose everything. So it is important that we can really answer all these kind of questions in seconds. Okay, so what are the possible solutions of the very expressive Deontic logic? And I'm going to talk about it in the next slides. And for the efficiency, we want to look for state-of-the-art theorem provers, so fully automated theorem provers. And now the problem is, first of all, is there, and this automated theorem prover are of course designed to reason over those Deontic logics. So now the first question is, does such a logic exist, or is there such a logic which is expressive enough to do all what we want? And in addition to that, it can be fully mechanized. So reasoning over that can be fully mechanized. And if it does, and then the question is, if there is such logic, if it can be fully mechanized. Okay, so this is the first question I would like to ask. And in my opinion, and there is no such logic that can be fully mechanized. So either you have a very expressive logic, or you have an efficient, non-expressive logic, but with efficient, with nice computational properties. So how do you solve this problem? And the solution that we chose is to not to solve it immediately. So to use a very high level, but formal, we can also call it a Deontic logic language, but a very high level, very expressive one, with no computational properties. And in this case, we even use JSON because we don't, JSON is just a format, very similar to XML, which just to capture all the properties that exist in the, either in the knowledge or in the problem. And this can capture everything, contrary to duty, obligations and exceptions, etc. But when a specific question is being asked, then you want to translate from this high level to a very specific logic, and many times, sometimes even different logics at the same time. And then this logic is very specific. It doesn't answer, is not that expressive, but is expressive enough to answer the specific question. And on the other hand side, it has a very good computational properties. So this is not a novel idea. It's used other places. So a very famous example is the temporary logic of actions of Leslie Lamport, where he is using a first-order model language over set theory in order to capture software and hardware properties. And then, and the questions you want to ask over these properties, like liveness and safety and termination, etc. And then these problems are being translated into different Torah improvers at the same time. So, for example, propositional, linear temporal logic, there are efficient tools for proving validity of that. This is one, but it's propositional, of course, and also different SMT solvers are being used at the same time, and model finders. And combining all this information, the tool actually managed to answer interesting questions and is used in different by different companies like Amazon, like Microsoft, etc. Because so the idea is not new, and again, the point here is to have a very expressive language, but when a specific question is being asked, translate it into different engines in order to be able to answer the question. Okay, about the automated Torah improvers, I don't have so much to say because this is not something that I create. I'm using state-of-the-art Torah improvers. Of course, the requirements are efficiency, and of course, that there are reasoning over the logic that actually is being used here. There is also a requirement, especially if you want to create a tool, a commercial tool later, is that they have permissive enough licenses, but this is not interesting to this talk, so I will not talk more about that. But this actually becomes an issue when you try to use them, and especially when you want to get some money for grants, etc., in order to develop this kind of tools. None of them like open source, for example. They want to have the IP of these things, and license is becoming important. Okay, so now let's talk about the Deontic logic. So given our solution to the legal reasoning engine, which we said can have a very high-level language and then focus on the certain problems only, we can now define some clearer restrictions of the logic that we want to use. So first of all, the logic needs to be expressive, of course, to capture specific problems in specific contexts, but it doesn't have to be all powerful and capture all possible legal aspects. So you can really try to modify it. And it also needs to be supported not only by one state-of-the-art Torah improvers, but hopefully by several different Torah improvers. Why is it important? First of all, if you have more than one, you can actually have higher confidence in its correctness. Also, it allows you to answer different questions, for example, validity, finding counter models, etc. And also, of course, it's important that it's a generally enough domain, so people will compete in order to create the most efficient Torah improvers. So, for example, in the automated Torah improver community, there are competitions for the most popular and most interesting logical domains. It's first order, higher order, model logic. And people really try to win these prizes, so they actually work in improving their Torah improvers. So what I want to do now, I want to mention one, the Deontic logic, which Matteo Pescucci and I collaborated on last year. It's clearly not, so why am I mentioning this logic? It's because it actually answers the requirements that I just mentioned before. It probably doesn't answer and doesn't satisfy many other requirements, but it's still good enough for what we need to do. So let me explain. What we try to do in this logic is to meet those philosophical requirements that you can find a lot in the literature. I call them philosophical, although they were created by people with lots of legal knowledge and logical knowledge. So like Carl Jones. So I'm not saying philosophical in any negative way, but what I mean here is that they focus on a certain problem from the legal domain, and then they started some kind of philosophical argument about this problem. And I don't think that in any phase of this, they actually try to build a tool based on this. I might be wrong in that, but this is just one example. So what we try to do is we try to, for example, take this article by Carl Jones and create a logic that meets all the 8 points of the requirements. They specify 8 requirements of the Deontic logics, and then they get their own solution, but their own solution was relatively complicated, so it required neighborhood semantics. So it had neighborhood semantics. And we try to do something simpler that can easily be captured by first order multimodal logic. Why first order multimodal logic? Because this is one of the domains that is popular and has some competition in and has state-of-the-art tools. And but it's also relatively rich, right? It's first order and multimodal, so it can capture a relatively rich issues and sophisticated issues. Relatively, of course, they are much stronger Deontic logics and much more expressive. Okay, so we have this kind of logic, and the main advantage of this logic is that it can easily be encoded into this first order multimodal logic, and then we can execute state-of-the-art Tor improvers. There is also theoretically support for model finders and other Tor improvers. So this might be an interesting, so this is an interesting venue if we actually want to have something practical. The disadvantage of this logic is that it doesn't answer, so it has contrary to duty and other obligations and other things supporting among others. But one of the most crucial things, if you really look on applications, is of course non-monotonic reasoning. And it is completely monotonic, it doesn't support it. So what's the solution? Instead of throwing the logic away, we try to do something else. So our problem, if I just rephrase it, is to have those nice philosophical properties which attest the quality of the legal expert, for example, or the legal reasoner. We also have to support non-monotonic reasoning because law is based on exceptions and other kind of things. And of course, it needs at the same time to be efficient, and we want to have a variety of Tor improvers, etc. And when we consider first order model logic, it seems to be on the boundaries between efficient Tor improvers and expressivity. So it's possible to encode, and it was done by people encode non-monotonicity in first order model logic, but it's challenging, it's creating a more complicated language, and Christoph Benzmuller will tell you later that the farther you go from simple formulae, the harder it will be for the Tor improver, of course, to prove it, and therefore you should use more expressive languages. So we don't want to need more expressive languages, and therefore we don't want to do very complicated encodings. So what is the solution? And this is the ongoing work, is to do a two-phase reasoning. Not one phase, but two-phase. What's the idea? This is again a current work with Matteo Pascucci, Tov Gabay, and Leon. And what we did so far, we extended, we invented, or not invented, but we came up with this solution for two-phase reasoning. And the second phase is to take a problem which does not require any non-monotonic reasoning, and the reason it doesn't require any non-monotonic reasoning is because it has a full knowledge over the case, over the situation, and therefore there is no additional knowledge cannot change the deduction because we already know everything. And in this case, we don't care about non-monotonic anymore, and we can just execute our current tool, our current logic. And the first phase is to come up with a standard problem into this situation where non-monotonicity disappears. And the idea of doing that is to try to complete the knowledge using Tor improvers. So we work on the propositional case, and we try to use SAT solvers in order to complete what is known in the current state. And in the current instant, we know exactly what is known. We don't need non-monotonicity anymore. So this is the basic idea here, and the challenge here is to extend it to first-order logic, which is much harder. Okay, so let's go now forward from the Deontic logic. Another component that, if you remember, after the engine answers the question, the M-link-COP, for example, produces a connection proof, which looks like that. Counter models are also not that simple. They contain lots of symbols and their own semantics. So we need somehow to translate it into a legal argument, something that the lawyer can understand. Based on this and these cases, we told you that and that. And if you add this, for example, claim, then it will be fine. So you will be able to show compliance, for example. So we need to translate the result also, but this seems to be much more feasible because the data, the input is formal, the output is formal, and you just need to come up with the right algorithm. You need to search maybe for the result, and there are different solutions that we are considering. For example, there is the proof search by the group of Dale Miller, which use proof search in order to certify proofs that can also transform them into different formats. And this is something that we are considering for this point. Now I'm going to the other side. Remember that I talked about point 7. Point 7 is the interface of the result. So now we are talking about the knowledge itself, and this is a relatively important problem. asking questions is important, but creating a high quality knowledge which will be used in order to answer this question might be even harder and more important. So we want here to formalize complex and quite a lot of legal knowledge and do this formalization in a way that will be understandable by legal experts and will also be well engineered. And I will explain quickly below what it means. We do have a tool. This is a collaboration with Alexander Steen from the team of Leon. And this tool is an annotation-based editor for legal texts. We call it NAI. If I have some time at the end, I can show a quick demo of that. The expressive language that it uses is JSON, but it has all these things like permitted. So it's the Deontic logic, but in a format which allows it to be infinitely richer, in a sense. And the tool won the first prize in the IRIS conference in Salzburg in the beginning of the year. So this is mainly a conference that is mainly frequented by legal practitioners, and they really like this direction of formalizing legal knowledge in a way that is understandable to the lawyers themselves, without understanding much about logic. So what are the advantages of this approach? First of all, it's faithful to the original text. You just have the original text and you annotate it. So you don't change it. You always have it in front of you. And it's also well engineered because it's a very high level process. You don't generate formulae. You don't add quantifiers. You don't add symbols. You don't change names. All these kind of things are happening automatically after you annotate it. So from the engineering point of view, it's much better. It's well engineered. So you don't repeat code. For example, many times you have statements where you have to repeat. And if I want to translate some kind of a legal statement into formula, I have to create many different formulas that represent that. And I can show you an example later about the GDPR. When you use annotations, you can have high-level annotations which capture all these kind of subtleties. So not only permissions and obligation, but also things like multi-obligation. There is some annotation which is called multi-obligation in the editor, which means that there are several obligations that arise from different conditions. So it's well engineered, and all the code, all the formulae are automatically generated. Okay, and the last point is about the legal knowledge and the quality control. So I put them together again because they're related. So what is the requirement here? The main requirement is that the quality of the knowledge needs to be on par with the knowledge of legal experts. We are not trying to replace legal experts, and we're not trying to replace all the knowledge of legal experts. Just take some of the knowledge. So for example, for answering some questions, you might need only a few articles of the GDPR. For compliance, for example, you don't need to know all the GDPR. You just need to know selected compliance articles. Of course, to know what happens if you violate the articles, then there are other articles explaining. Okay, so you might need only a very restricted amount of knowledge, but the quality of this knowledge needs to be very high. And you also need to think that the knowledge changes all the time because you need to take court cases into account, and also the legislation changes. And also, we never have complete knowledge. The knowledge is almost infinite, and the finite human resources capable of inserting the knowledge, formalizing the knowledge. So we must build a system which can edit incrementally. So starting with one article, show that it's useful, add more articles, etc. And the point here, and I'm not going to talk about it much. If somebody's interested, we have several papers about that, and this is a really interesting topic in my opinion. But the solution here is to do legal engineering, so new legal engineering practices. So what is legal engineering? There is already a term like that, and the term refers to a combination of legal and technology expertise. So people claim that the future lawyer will not be a lawyer, but it will be a legal engineer, which means that beyond the legal expertise, they will also have technological expertise. They will know how to use different tools. But here we mean a different definition. So when you talk about software engineers, what you mean here are people who knows how to write code, but also use specific engineering methodologies in order to write the code. Not only tools, not only technology, but also methodologies. And normally the methodologies come with tools, so maybe the definitions are not that different from each other, but I still think that there is some distinction. And when applied to the legal domain, it means build and maintain legal knowledge using specific engineering methodologies, exactly like in software engineering. And what kind of software engineering, and the main idea here is that you can adapt software engineering is an older, much older domain than legal engineering, in my opinion, or at least I don't know much about legal engineering methodologies, but I know quite a few software engineering methodologies, and I think many of them can be adapted to the legal engineering domain. For example, and this is again an ongoing work with Alexander Steen, behavior-driven development is a very popular nowadays software engineering methodology where you write executable test stories of how your code should behave. So if I want to write some program, I write some stories. This program, when it gets with this web page, when I put this information and I click here, I go there and I see that. So these are the stories, but they are not only textual stories, they're actually programs which can be executable. So my program at the end just need to pass all the tests. So this is much simpler in software engineering and in the legal context. We know that. But we believe that it's possible to use it up to some extent also in the legal domain. So for example, you can imagine taking again, you might have bias here, but you might imagine taking all the court cases, decisions, make out of them executable stories, and we can already execute them because we have this tool that if I have time I can show you. So you create out of these court cases executable stories, and then you need at least that your legislation meet all these court cases. Of course, some court cases can be wrong, so you need to, it's not that simple as I said, but it might be one way towards legal engineering methodologies. Okay, so this is, I finished going over all the points. I will just summarize what I mentioned. So this there is this ongoing project to create a proof of concept. I try to apply for the Luxembourgish research fund for proof of concept project, the 2-year project. The website is icomply.eu. And industrial collaboration is I have identified 3 interested stakeholders. So data protection authorities, auditing firms, and some law firms. And I have one representative from each one of them. So the Luxembourgish Data Protection Authority, CNPD, KPMG is an auditing firm, and some law firms. And what are the milestones for the 2 years? So after 1 year, I already want to have a basic prototype capable of processing business process diagrams. They're easier because they're semi-structured for GDPR compliance based on the main GDPR articles. I'm going to identify the 8-10 main GDPR articles and be able to answer some questions over them. After 18 months, this prototype is going to be integrated already in the stakeholder environment. So with all these interfaces for replying, for the response, and for inputting the problem. And after 2 years, it's going to be stretched with some NLLP, so natural legal language processing, which will allow it to deal with some other privacy documents, and also to extend to more GDPR articles and also some local laws and court cases. Okay, so what's the challenge? The challenge is to go from the current state, which I will show in the next slide, of technological readiness level, to the prototype level, which is level 7 out of 9, within 2 years over all the points. So these are the 10 points that I mentioned. You can see them above, and this is a table explaining what are the different technological readiness levels. And we need to have at least TRL 7 on the right-hand side. On the user side, we need to have, and right now we have a very low one. We have 1 on many of the topics, and we need to get to 7. On the other side, we have a relatively higher one. We have 6, and we don't really think it's urgent to improve it in order to meet the challenges or the milestones that I just mentioned. Okay, so I think this is everything. So thank you very much. And Ali, do I still have some time before I answer questions? I can show us a quick demo. Or...
Yeah, that's almost 40 minutes. So you could also have 1 or 2 more minutes, or we could start discussion.
Okay, so let me just do a very quick demonstration of the tool. So this is a tool that Alex Steen and I created. So what does it mean to use a very high-level annotation language? Here you have article sorting of the GDPR. You can see all the article and you can see the annotations over this article. These colorful things are the terms, and then you can have different annotations. So as you can see, this is just a legal text with, let's just show you an example of an annotation. You can click connectives, you have obligations, permissions, but you also have more complicated one like this macro for multi-obligations, exceptions, etc. And these are just those annotations that are required in order to be able to deal with, sorry, I'm not very good with iPads. How do I close it? Yeah. And then you can go here and you can see the result. So this is all fully automatically going to a specific language. So on the left-hand side, you can see the sentence, and on the right-hand side, you can see a very, very long formula. And this formula is long not only because it contains symbols, but also because there are actually 6 different formulas, a conjunction of 6 different formulas. So this text was generating even more than 6, I think 9. So yes, so this is the idea of using a high-level language in order to automate the generation of the formula and use annotations in order to do that. And what kind of questions? So this is a tool that is not, this is only the left-hand side, the one for creating knowledge. You can also, of course, work a bit with that. So for example, you have one query. I use annotations, but they are not very informative. So let's look, how does it look like? So here I want to ask some assumption. If I don't already know the purpose of some processing, is it permitted for the controller in this case to communicate within a certain time the purpose of the data? Okay, so this is the question I'm asking here. And with the certain time is within 1 day after the second processing. So I ask a very specific question about if it's permitted or not. So I can, this is one of the compliance questions, is if something is permitted or something is forbidden. And then I can execute the query and I can get an answer here. I believe that this one is not compliant. Yes, this one is not compliant. So actually we need to execute a counter model finder. So the prover itself cannot find it, and we don't support yet model finders. But if we would execute a model finder at the same time, it would easily find a counter example. Now, if I go to the second query, here I'm asking something, if it's permitted to communicate before the second processing time the purpose of the data, in case we don't already know that. And then when we execute that, this is valid. So the tool tells you, yes, this is compliant with the law, at least the one that we wrote down. Okay, so this is just a very quick demonstration only of the left-hand side and the legal reasoning part. Clearly, no user is expected to actually put formulae inside, so the interfacing part is extremely important. Okay, thank you very much.
Thanks, Tomer, for your nice presentation.